Good evening guys to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So guys, today is the last technical session for ESE paper as you are having engineering services paper for 23 just day after tomorrow on Sunday. So for all other subjects already technical sessions are been completed. So this is the last session where we are going to cover the questions from the strength of material production and machine design. From these three topics we will be having the problems solution in front of you now. So guys, do like and share the session so that other students can also join it. This is some detail about me, and today's topic will be having the questions from SOM, MD and production. This is specifically maybe for like ESE paper, but similar type of questions are coming in the BARC as well, and also the similar questions are coming in ISRO as well. So this will be helpful in that as well. So guys, up to 90% of the scholarship if you want to get on the GATE and ESE preparation for 2024, then on 20th February you can appear for the scholarship test, which will be at 7:30 p.m. and you can register now for it for free. The link is there in the description box. Maniket, good evening dear, how are you? So guys, moving further, I would like to tell you those who are looking for preparation of BARC. For BARC preparation, we are coming with Brahmastra series from 21st of February. Okay, so from 21st Feb we will be coming with Brahmastra series, where we will be having the wonderful sessions of all the chapters, all the topics, all the subject for those students who are appearing for the BARC examination. So guys, this is the very first question in front of you. This is related to strength of material. So Maniket, you need to answer this question. In the arrangement as shown in the figure, the stepped steel bar ABC is loaded by load P. The material has Young's modulus of 200 GPa. The two portions AB and BC have areas of 1 centimeter square and 2 centimeter square. The magnitude of the load P required to fill the gap. Okay guys, so this is the question actually, and you need to find out the value of P for which this gap will be filled. We know that until this gap will be filled, there will be no reaction from this support. So we can say we need to go for delta 1 plus delta 2. If this is bar 1, this is bar 2. Delta 1 plus delta 2 is equals to the gap. The gap is 0.75 mm. Okay, and I feel everybody is aware what is delta 1. P1, L1, A1, E1. I am giving you just hint to solve it. Then P2, L2 upon A2, E2. So when you will be solving this, equating it with 0.75 mm, you will be getting the value, of P. This is how you will be solving it. Yes, so all the students try to solve it, and this is the hint I have given you. This is the case of bars in series. Such type of questions are coming in ESE paper. Okay, so you need to have a habit of small calculations. So if you see, my dear, for equilibrium of the body there should be a support reaction that is equals to RA, and for equilibrium of the body RA should be equals to P. So Abhi have already answered it as B. Okay, what about others? So if you will be taking the section, this is going to be section, this is going to be section. So my dear, if you will see this section to the right hand side, there is no force. So directly we can say P2 to be 0. So because of this, this part is directly 0. So we are having only P, L upon A1. P is same, L1 is 1 meter, A1 E, that is equals to 0.75. You will be equating it, you will be getting the value of P, क्योंकि आपको length भी given है. You are given the length, you are given the Young's modulus. So Maniket and Abhi both have answered it as B. So answer is correct. Yes, B is the right answer. Very good, Abhi. Moving to the next case, next question. So guys, next question is related to elastic constant. The number of independent elastic constants You will say this is very easy question, but ESE asked this question. Then what I can say? What ESE is asking, the same I am presenting in front of you. The reason is, in ESE, you need to solve 150 question in 180 minutes. Very good, Kiran. So after so many days you came, dear. If possible, try to share with me how was your GATE examination. Good evening, Kiran. Okay, talk to me after the class if possible, or tomorrow. I need to know how was your exam. So the number of independent elastic constant, you know, when the material is homogeneous and isotropic, total elastic constants are 4: E, G, mu and K. Out of these 4, if you know any 2, we can find out other 2. What are the elastic constants? The relation E is equals to 2G, 1 plus mu. E is equals to 3K, 1 minus 2 mu. So my dear, E is equals to 9 kg, 3K plus G. So the point is, if you are aware of any 2 elastic constants, let us say you know E and K. If you know E and K, you can find out mu and G. So that is why if you know any 2, you can find out other 2. That is why 2 is the independent number. Similarly, if the material is orthotropic, then you will say 9 out of 12 are independent. If material is anisotropic, that you will be answering in the next question. You will be answering in the next question. Very good, TPM. So moving to the question number 3. Moving to the question number 3. Tell me, guys. Abhi is saying C is the answer. TPM is saying C is the answer. Kiran is saying C is the answer. Maniket, I am waiting for you. Maniket, I am waiting for you. Very good. So answer is C. Actually, they have not written the total number of independent constant. So in reality, answer should be 36. But 36 is not in the option. Then we will go for the 21, which is independent. That is there in the option. Moving to the next question. Once again from elastic constant. You know E is equals to 2G 1 plus mu. They are giving you the value of E and G. You need to find out the value of mu. Yes. So guys, just after the exam, when you will be coming out of ESE paper, at 5 PM we will be live to tell you the solution of paper, technical paper and also the paper 1. Yes. Very good. All of you have given the right answer. It is 0.2. Whenever you will be putting 120 is equals to 2 into 50 into 1 plus mu. You will get mu to be equals to 0.2. Very good. Moving further. This is a very good question. He is asking about the pure shear condition. Which of the following is correctly representing the pure shear? Pure shear. Pure shear. Pure shear. Pure shear. Let us see how many of you will give the right answer for this. Very good question. TPM, there is minimum marks needed is 15%. If you want that your both paper 1 and technical paper should be checked, for that you must score at least 30 marks in the first paper, paper 1. But with 30 your selection is not confirmed. 30 will ensure the checking of the second paper. Now from the first and second paper together, they will be checking the total. In general, if we see the last year's total, then those students who are getting more than 250 to 260 marks, they are going to the next step, that is conventional. But I will say maybe it can increase to 20-25 marks based on the level of the paper also. So the answer for this is going to be B. Okay? Because there are two cases. One is this, which can be represented as pure shear. Second is this, which can be represented as pure shear. So there is no case which is saying epsilon xx and yy to be 0. So we will be saying the answer, correct answer to be B for this. Moving further, guys. This is related to the torsion. So let us see how many of you give the right answer for this. This is from the torsion. Okay, this was question number 3, 4, 5, 6. We are having around 25 questions, not more than that. Kiran is saying B, बहुत बढ़िया TPM. Kiran is saying B. Yes, Kiran is saying B. What about others? Kiran is saying B. Maniket is also saying B. So if you see the answer, how you will be solving it, you are having a circular shaft. We are having a circular shaft subjected to a twisting moment, because of which maximum shear stress will be coming out to be 60 MPa. You know this comes, and this state of stress is given like this. So we can say for this sigma 1 is plus tau, sigma 2 is minus tau. It will be plus 60, minus 60. The answer is B for this. Okay. Yes, pure torsion condition. So guys, Sonu sir is also there in the comment section. So all the times, day or night, all the faculties are joining live to increase your confidence, your motivation. Next question. A system under biaxial. Okay, this is question number 7. A system under biaxial loading induces principal stresses. Directly sigma 1 is 100, sigma 2 is 50. It is plus 100, it is minus 50. And they are asking you the normal stress on the plane of maximum shear. Sigma star is asked actually. Yes, you know that sigma star is the center of Mohr circle, and it is given as sigma 1 plus sigma 2 by 2. Yes or no? And if you will be going for sigma 1 and sigma 2, it is 100 minus 50 by 2. 25. D is the right answer. Here I feel अभी धोखा खा गए, अभी धोखा खा गए, TPM भी धोखा खा गए. Answer will be D here guys, because one is tensile, other is compressive. Mohr circle will be like this, so center will somewhere here. Mohr circle is saying this is 100, this is minus 50, so center will be at 25. 75 from here, 75 from here. So answer will be D. So this kind of mistake you can do in exam also. Try to avoid it. Okay. That is why I have kept this question. Next is thin cylinder, question number 8. Question number 8, thin cylinder. You need to tell the ratio of hoop stress, cylinder to sphere. Cylinder to sphere. Let us see how many of you give the right answer, guys. Hoop stress, cylinder to sphere. Hoop stress, cylinder to sphere. Kiran is saying answer is 2. C. TPM Maniket अभी. बहुत बढ़िया. Answer is C. आपको पता है, you know, for cylindrical PR by T, for spherical PR by 2T, ratio will be 2:1. Moving further to question number 9. That is from SFD BMD. Which of the following relation is not correct? I feel everybody is aware of these things. Question is from SFD BMD. SFD BMD. Abhi is saying C. Sorry, A. Kiran is saying C. Dear, A is the answer, because we already know WXX is dV by dx. Vx axis dm by dx. So Wx axis d square m by dx square. All these relations are correct. This is the wrong one. Moving further to question number 10th. Yogesh, I feel that civil faculty you should ask there, okay? So this is the session going on for mechanical, I feel. Okay, next question is this. So simply supported beam of 8 meter length carries 3-point load 8, 4 and 10. Okay, even Yogesh, if you are from civil, this question you can solve if you are appearing for ESE, it may help you. 8 meter is the total length. There are 3 forces, 8 kilonewton, 4 kilonewton and 10 kilonewton. This is at 2 meter, at 5 meter, and next one is at 6 meters. I feel you can find out the support reaction at A and B very easily. RA, principle of superposition, apply that. TPM remembered the year also, very good. So answer for this is going to be D, that's correct. And it is going to be plus 8, distance from opposite end is 6, total length is 8. Plus 4, distance from opposite end is 4 divided by 8. Plus 10, distance from opposite end is 2 divided by 8. So answer will be coming out to be 10. So you know RA plus RB is 22. So RB will be 12. D is the right answer. Moving further, guys, this is from shear stresses of beams. Question number 11 it is. We are still left with 13-14 more questions because total questions are 25 from 3 subjects. Rectangular section is given. You know, for rectangular section, maximum shear stress is 3/2 of average. Tau average is shear force but area. Solve it and get the answer. Sarthak is saying 0. Dear, he is asking shear stress on the neutral axis. If you have a rectangular section, shear stress distribution is given like this. Shear stress is going to be maximum on neutral axis. What you are saying is correct for bending stress. For shear stress, this is the distribution. And this is tau max. So 0 is correct for bending, not for shear. I feel they have given a 5 centimeter width, 10 centimeter deep, 10 centimeter deep, 10 centimeter deep. So when you will be applying this, shear force is 2000 kg. BH is 5 into 10. When you will be putting this value here, the answer will be C, 60. 60 kgf by centimeter square will be the right answer, my dear. Okay, I feel everybody is getting it. Moving to question number 12. Moving to question number 12. Here, while transmitting the same power by a shaft, you know power is T into omega. T, what is T? T by ZP is tau max. So you can write T to be tau max into ZP. So power is directly proportional to tau max ZP into omega. So directly proportional to ZP is pi by 16 d cube into omega. Use this relation to find the answer. Use this relation to find the answer. Solve it, guys. And do like and share the session. This is question number 12. Yes, guys. Yes, guys. So, you know that what should be its new diameter if maximum shear stress in the shaft is same. This is same. That's why I said it ZP into omega. So you can say d cube is equals to this. You are said that speed is doubled. So omega 2 is 2 times omega 1. So it is 2. So d2 is d1 cube by 2 to the power 1 by 3. So the answer is D, 1 by 2 to the power 1 by 3. Very good, guys. बहुत ही बढ़िया. Moving further to question number 13. Question number 13. Question number 13. This is from column. This is from column. There are two conditions. Both and fix. Second condition. This. For this buckling load is pi square EI minimum. LE ka square. This is the formula. For this case, LE is L by 2. For this case, LE is 2L. Tell me what will be the answer. Graham Bell. Okay. What will be the answer for this? So when you will be taking the ratio, both end fix, column with one end fix and the other end. The ratio of compressive critical load for a long column fixed at both ends. Fix. Fixed to free. When you will be putting the value, it is, when you will put L by 2, it will be coming out to be 4 by 1 by 4. 16. Are we getting D? Yes, here L by 2. D will be the answer, na Kiran? It is D, L by 2, na? So when you will put L by 2, it will become 4. And here 2L in the denominator. So 4 into 4 will be 16. Answer is D. Moving to question number 14. This is from SFD BMD once again. The maximum bending moment for a beam subjected to UDL. What is the answer? What is the answer, guys? After that, 11 questions are more. Graham Bell is saying answer is A. The same is Kiran, TPM and Abhi are saying the answer is correct. So for this case, the maximum bending moment will be WL square by 2. Very good. So moving further guys to question number 15 from material science. Material science. Yes. He is asking what is a surface imperfection which separate crystal of different orientation in a polycrystalline aggregate called. Is it edge dislocation, stacking fault, grain boundary or screw dislocation? Yes, I taught you in the material science marathon. Different orientation. Grain boundaries are said to be the region of orientation mismatch. Remember or not? So answer will be grain boundary. Yes, Ganesh. Very good. Okay, Abhi, it's fine. Still you come. That's great. Moving further, guys. Next question is once again from material science. Question number 16. TPM, actually staking fault is not about that what you are saying. Staking fault is if a material is not following the staking sequence. And when we are talking about staking sequence, it is generally coming because of improper positioning of chills. So if you have that doubt, you can share it with me. I will try to help you. Okay. You can share that with me on Telegram or WhatsApp. Okay. Rambel is saying C, Kiran is saying C. Yes, you know, iron carbon diagram is equilibrium diagram. Triple D diagram is non-equilibrium because here we are going to provide the transformation at different rates of coolings. Moving further. This is question number 17. Geomini test is performed for what? Geomini test is performed for what? This is from heat treatment. Very good, Graham Bell, Kiran. Geomini test is performed for hardenability. Moving to question number 18. Machine design. Machine design. Shekhar Sharma, very good. He is asking for brittle materials. Which theory of failure is going to be better? Graham Bell is saying C. Ganesh is saying D. Okay, hardness. Dear, for last question, answer is hardenability. C is correct. Geomini test is done for checking the hardenability. Okay. What is done in that? We are having a surface, we heat it with the flame or current, then instantly we cool it with the water spray and we see how much layer is getting hardened. So more layer means more hardenability. So answer for this is A. You must be aware of, for brittle material MPST is preferable. For ductile material, MSST is preferable. And if you are writing MDET, it is preferable for economy. It is preferable for safety. It is safest. बहुत बढ़िया. Next question, guys, once again from machine design. Two shafts A and B made up of same material. Diameter of A is twice diameter of B. So you know torque is directly proportional to ZP. Answer it accordingly. Answer it accordingly. Yes. So what will be the answer, guys, for this? You know ZP is given as pi by 16 d cube. Torque is directly proportional to d cube. Diameter is becoming 2 times. This will become 8 times. Moving further, guys, casting production question now. This is question number 20. Casting defect. Misrun is happening because of what? Very good, Shekhar. Very good. Misrun is coming because of what? I am telling you, misrun is this defect. When molten metal is unable to fill the cavity completely, this defect is said to be misrun. So this happened because of what? Graham Bell, Kiran are saying because of B. Shekhar, Ganesh, TPM, Maniket. बहुत बढ़िया. Ganesh is also saying the same. The answer for this is B, insufficient fluidity. This happens because of insufficient fluidity. Very good, TPM. Very good, Ganesh, Kiran, Graham, Shekhar, Ganesh. Moving further to question number 21 from rolling. As Kelsey is not allowed, very less numericals are there. They are asking you the maximum draft per pass. Maximum draft per pass. Yes. The answer for this is delta H max is mu square R. D will be the right answer, guys. Very good. Very good, Shekhar, Ganesh, TPM, Maniket, Grambel, Kiran. Moving to question number 22. In rolling a strip between two rolls, the position of neutral point in the arc of contact does not depend upon. It will not depend upon the amount of reduction, the diameter of the rolls, coefficient of friction or material of the rolls. Position of neutral point will not depend on which of the following. Tell me that. The answer for this is D. Material for the rolls. Okay, because the position of neutral point will depend on friction for sure. So definitely it will depend on this. So it will not be depending upon the material of rolls. Moving to question number 23, guys. About hot extrusion. Which of the following lubricant is used in hot extrusion? After that, we have two more questions. Graham Bell is saying the answer to be A, which is correct. Molten glass is used for extrusion of steel. Wonderful, wonderful. Moving to question number 24. Welding. You know Hg is I square RT. You need to find out I. it is given resistance is 200 microohms, T is 0.2 seconds. Find out the value of current. All of you are saying the answer to be 5,000. Very good. Moving to the last 25th. इनमें से कौन सी टर्म ग्राइंडिंग में नहीं आती? Which term do not comes in grinding? So my dear, truing, dressing, glazing and buffing. Grinding. Dear, answer is buffing. Actually, whenever we are going to remove a layer of the grinding wheel to make the edges sharp, this process is dressing. And to make it cylindrical, the process done is truing. There is something called as buffing which is not happening in this grinding operation. Moving to the last part, powder metallurgy, question number 26, bonus question. If you want to improve the bearing property, very good TPM. To improve the bearing property, you will be going for pouring the oil in the bearing, and that process is oil impregnation. So guys, you have done it nicely. So this is over for tonight. Day after tomorrow you are having the exam. So I would say best of luck for that to you guys, and try to give your 100%. And when we are talking about ESE paper, it is more about the horizontal depth of syllabus, means more topics you need to cover into lesser depth. So take care of that. And now I feel the paper is coming now. Nothing you can do except more than revision. You cannot do anything. So tomorrow take proper rest also tomorrow night, so that on the next day you shall not feel sleepy at the time of exam. Okay. So goodbye, good night for this session. Thanks for joining. We will meet once again in Bark series. The name of the series is Brahmastra. We will be meeting from 21st of Feb. TPM generally it goes around 250 to 260 marks. It is general. Okay. It may vary based on the level of paper, but generally it comes around 250. So goodbye guys. Good night guys. We will meet once again. And after your exam, you can join us. We will be meeting live to give you the solution of the paper. Goodbye.